can't skip this guy.
Ladies and gentlemen, please welcome Robert Gregg, Chief Aerodynamicist at the Boeing Company and Aviation 2015's Forum 360 Chair.
Good morning. Well, here we are. It's hard to believe that it's been a full week already. It's the last morning of aviation. During this week, you and more than 2,000 of your fellow aerospace professionals have had, well, they're from 39 states, the District of Columbia, and 41 countries, have had discussions to better understand the future direction of the aviation enterprise and the state-of-the-art of science and technology. Through our 5 plenary and 9 Forum 360 panels, along with the technical sessions and paper presentations, formal and informal collaborations in the hallways, and your discussions throughout the week, it is my hope that each of you have come away from Aviation 2015 with a better better equipped with the knowledge you will need to keep actively shaping the future of aerospace. And we are glad that you made the choice to be here to benefit from the forum. As we near the end of our time here in Dallas, we should reflect that Aviation 2015 has brought together the right people from around the world, in industry, academia, the government, and that our discussion of mission-critical topics have been timely and relevant to the community. It should lead to further technical and scientific innovation and evolution. Also, let me take this last opportunity to sincerely thank the sponsors of Aviation 2015. Special thanks to our premier sponsor, Airbus, and sponsors Bastion Technologies, the Boeing Company, Crean and Associates Aerospace Consultants, Dunmore, HondaJet, Lockheed Martin, TMAC, and XFlow. Also, Aerospace America, our media sponsor. Let me almost take the opportunity to thank one last time all the volunteers who've served on the Executive Steering Committee, the Forum Organizing Committees, and the Technical Program Committee. Please join me in giving these individuals a round of applause for the hard work that went into planning this year's outstanding event. Two housekeeping items. As a reminder, you saw the pre-plenary slides. When you have a question for our speaker, please direct them to the web browser, our new Conference IO site at AIAA1.cnf.io. You will be able to submit and rate your favorite questions there. Those watching on live stream can do the same. Second, all of our speakers' biographies can be read by visiting the Aviation Forum website at aiaa-aviation.org/speakers. If we have learned anything about aviation this week, and I know we have learned how important civil aviation is to the United States, amounting to 5.4% of our nation's gross domestic product, GDP, contributing $1.5 trillion in total economic activity and supporting 11.8 million jobs. These significant numbers demand that we all can be ensured that flight remains fast, reliable, and safe. To talk about the company's role in civil aviation enterprise and how it is helping drive the state-of-the-art in flight technology forward, and to tell us the story of this year's Collier Trophy winner, the G650, please welcome Kurt Erbacher, Vice President, G650 Aircraft Program, Gulfstream Aerospace Corporation. Kurt?
Thank you. Thank you. Well, good morning, everyone, and thanks for having me, and thanks for listening to about the 650. Just a quick introduction. We started the design of the 650 in May of 2005 when we got approval from General Dynamics, and I was lucky enough to be on the program from the start to the finish. So a lot of history, a lot of great things, a lot of lessons learned. These programs are tough, they're not easy, and the reason the first slide I'll show you is the reason why the program is so successful is because we had a great team. There's not one person that can stand up and say they wore the 650 or contribute to the success. It was the team. And I've worked with quite a few development teams in my life over the last 30 years, and I have to say the 650 is probably the best team I've ever worked with. So let's go through it. I got slides to go through, then I have a quick little video to show you, and then I guess we'll go through questions and answers. So anyway. There's the 650 team. You can see our demonstrator airplane. I have 6,004s in the background, but I thought I'd start with the team because to me that was the most important, the most successful part of the program, and they deserve most of the credit. So, and that's outside our flight test hangar in Savannah, Georgia. The program, in general, we went into service at the end of 2012. Today we have well over 100 airplanes in service, and the customers love the airplane. It's continually breaking speed records. Left and right, the plane has an MMO of 925, and most customers are cruising at speeds about Mach 9.0 on their missions, and we'll talk about the mission of the airplane. The other thing we worked on was cabin noise. It's very important to customers about cabin noise, and we'll talk about what we've done in the cabin of the airplane during development. And then, like I said, most customers say it's a privilege to fly the airplane, the fly-by-wire system and the control system of the airplane. It's great performance. Just 2 days ago, we were going through Canadian certification of the 650, and we had the Canadian government up on the airplane on the 650, and they were flying at 51,000 feet with 45-degree banks and commenting on the stability of the airplane. So plane handles extremely well. Also, for pilot training, we worked with flight safety. We have 3 simulators already built. 4th one's on the way, and actually we're looking at a 5th one now over in the UK. So quite a bit of action going on with simulated training for the 652. So let's talk about the highlights of the airplane. Design, let me first say that Gulfstream itself has never built a new airplane. The last new TC airplane was built by Grumman Aerospace called the G2. Every other airplane since the G2 has been a derivative of the G2, including the G5, the 550, the 450, they're all derivatives of the G2. So when we started the 650, this was the first new jet that Gulfstream itself had designed. So our first rule was we're going to design the whole airplane in 3D in CATIA V5. And then we looked for the longest range airplane possible at highest speeds. So we looked at 7,000 miles at 8.5 and 6,000 miles at 9.0. Keep the weight, empty weight of the airplane at 54,000 pounds, max takeoff weight of 100,000 pounds. And then we worked cabin noise. We wanted dB levels below 550, cruising at higher speeds. Well, we'll talk about that later. We got a provisional type cert in November of 11, and then we got our certification on September 7th of 2012. So we started launching airplanes actually in November to customers that year. Field performance, the plane handles spectacular. We'll talk about that a little bit. And then one of the things we did when we decided to build this airplane is we wanted half the parts in this airplane that are in the 550. So, and we met that objective, which is pretty important. So in general, I talked about speed, talked about range, cruising speeds, new cabin windows, made them larger, spread them out. I have a slide talk about cabin windows. Talk about fatigue inside an airplane on a long-range mission has to do with cabin altitude. The 650, you're cruising at 41,000 feet, has a cabin altitude less than 3,000 feet. At 51,000, it has a cabin altitude of 4,850 feet, which is the lowest in the industry. In addition, we've pitched the windows out. We spread them out to give us more seat pitch. And then first time ever, we've changed the fuselage at Gulfstream. We actually stretched the fuselage 14 inches. So it was a big change for us there. We refer to this as a walk-around chart, what we've done to the airplane. And the first time ever, we introduced a 3-axis fly-by-wire system with a fully electronic backup. We're the first business aircraft to certify a fully electronic backup system. Also, we put some more composites in the airplane. The horizontal is a drooped composite horizontal surface, spars and covers. We went with new engines. We picked a Rolls-Royce BR725, and I have a slide we'll talk about engine development. We increased the baggage compartment size. We put a whole new wing on the airplane, put a whole new cockpit on the airplane, put a whole new entry door on the airplane. In general, we have basically a whole new airplane, but it didn't start this way when we got it out of PD. I hate to say that, but we changed everything on the airplane during the development and didn't get any budget or any schedule as a result of that, which was kind of interesting, but challenging. What is speed today? What's it mean to cruise between 8.0 and 8.5 on a long-range mission? It will save you an hour in the airplane. That's a big deal. We talk to customers all the time. Customers helped design this airplane. We got their feedback, and every one of them talk about speed. Speed is everything. And that's why when we look at the performance of the airplane, how they're using it today, most customers are cruising at Mach 9.0. Wind tunnels. We spent a lot of time in the wind tunnel, and we went to 9 different tunnels. We spent over 1,400 hours validating the design, the performance of the airplane, the handling characteristics of the airplane. We went all over. From Boeing to ETW and NASA to over in Holland and Netherlands, over to Germany for the cryo testing. Quite a bit of testing was done. The highlight of this is we also performed a lot of CFD on this airplane, thousands of hours in CFD. And what's amazing, what we learned is the engineers did a great job. The CFD predictions matched what was in the tunnel. There was nothing there that was different, which is was a tribute to the engineering. I mean, it was amazing how close the CFD matched the wind tunnel testing. And here's just a little breakdown of what each test was, and each, if you want to ask questions, we can talk about those, but this is what we did in each wind tunnel. On the G5, though, we did spend almost 1,600 hours in the tunnel. So you can see we spent a little less time than the G5, but we got great results. Talk about the airplane systems. In Savannah, we have 14,000 people now in Savannah working for Gulfstream. We've built a campus for engineering. Basically, we have 4 research design centers. We have labs. There's about 1,200 engineers in these labs and doing design of the new products. We also built an acoustic chamber. Interesting enough, that was critical for us to get our cabin noise down. And to support that, we have a great parent company called General Dynamics. We did hire some of the engineers, acoustic engineers from the submarine division. As you know, they're very acute for noise, so we hired them, and we learned an awful lot about the cabin. Well, I'll show you a cabin slide. So we also built since we've never done fly-by-wire in Savannah, we also built a demonstrator airplane and put a fly-by-wire system in it. And we flew around for about 2 years experimenting with fly-by-wire so we can get familiar with certifying an airplane with fly-by-wire. The engines, Rolls-Royce engines, 16,900 pounds of thrust, a lot more takeoff thrust than we had on the 550. It's very fuel efficient. It's got a good carbon footprint. The NOx levels are much lower. It's much quieter. Its flyover noise is half the flyover noise as a 550, to give you an idea on the 650 on community flyover noise. So Rolls, I have to say, did an outstanding job. They beat the SFC guarantee that they signed up for, and the engines came in, each one came in 100 pounds underweight. So my hat off to Rolls-Royce in that program and did an outstanding job developing that engine. The cockpit, we have PlaneView 2 in this airplane. Basically, we have 4 screens, 14-inch DUs displays up front. It has EVS and synthetic vision, which are standard with the heads-up display. We did change, we put a multifunctional standby controller, which is your standby instrument, but it also can be used for other commands inside the cockpit. So that's a first for us. And then, of course, we don't have manuals at all in the airplane. Everything's done through PlaneBook. We give 3 in the airplane. They have power outlets. Did a great job. And as a result, from fly-by-wire, the pedestal was greatly reduced inside the airplane and given more room to the pilots. Here's a picture of the cockpit today. You can see it. You can see the HUD, the 4 displays. Talk about enhanced vision systems. Interesting enough, with EVS, it allows us to see through basically small particles of fog and rain. Gives better, we can make a decision at 100 feet. And interesting, I'll tell you, you notice the bump on the nose, upper nose of the 650, and on the 550 and 450, the bumps on the bottom of the airplane where we have the EVS. It's not there because of parallax. The bump was put on the top of the 650 because when you hit a cruise speed about Mach 9.0, you get a shock wave if the bump was on the bottom, and it would hit the landing gear doors. So when we originally started with this airplane, that bump was on the bottom, but when we went in the wind tunnel and we saw the speeds we were seeing, we moved it back up top because we were getting a big bump on the landing gear doors. So anyway, the drag rise was huge. In addition, we have HUD. The HUD's a pretty neat system. Comes down, we have all the instruments on it, and then the EVS system display is displayed on the HUD, and it also displayed on the DU, so the pilots see both. As we go through development, and software is driving basically everything in the airplane today, we built basically what we call an integrated test facility. It's a stationary simulator where we take all the components and software coming in from the various suppliers, from the flight control computer from Thales, from the cockpit from Honeywell, to the REUs from Parker Aerospace, and we integrate that in, and we basically have a standing simulator, it's motionless simulator, and we can do all the software integration inside at there at Gulfstream, and that is called our integrated test facility. Talk about the flight control system. We spent a lot of time on it, and to us it was the highest risk on the whole development side of the program. It turned out much better than we wanted, but we spent a lot of time and focus on it. When the FAA flew it during development testing and certification, we had to go into full electronic backup mode, and the pilot, he's retired, Clark retired, but he came back and said he didn't even know he was in backup mode. It felt he had full authority like he was in normal mode. So flight control system went extremely very well during this development program. We talked about the ITF. We developed a software integration, actually for the Iron Bird. This is called an Iron Bird right here. This is where we did the flight control system. It's a full-scale representation of the 650, hydraulically driven, has all the surfaces on it, and actually we can simulate air loads on the surfaces too. So this is what we use to integrate and validate the fly-by-wire system. We spent literally about 20,000 hours on the Iron Bird before we got certification. So what are the benefits of fly-by-wire? Because when we originally started the 650, from the day we started in May, it was not a fly-by-wire airplane. As we got through the regulations and looked at what we had to change to go to fly-by-wire. But what were the benefits while we went into it? Obviously, handling qualities. You can tune the system. We tune the airplane basically to the owner's seat. So he has the smoothest ride in the airplane. You can actually tune the controls to do that, gust loads. Keeps you out of areas, has envelope protection, which is fantastic. From maintainability, when we want to go ahead and rig the flight controls, we push one button and it does an auto rig based on the sensors. And it does have a marginal weight savings. You get into back and forth because you got to put a rat in the airplane and you have to put battery backup. So, but it does have a marginal weight savings. And then this is, we call this the back of the airplane, we call this the boiler room. This is what it looks like when we put the systems in CATIA. Not that, I mean, today everybody's doing it. Back in '06, though, it was a big deal for us. And you can see how crowded and space gets into the back of the boiler room when you put all the systems of the airplane. So it proved to be very beneficial for us. Like I've told you, we changed the fuselage for the first time. We did it in a three-dimensional CATIA V5. To be frank, we made our senior managers at Gulfstream very nervous. This was a quantum leap for us. So what we did was, from a manufacturing standpoint, we built the test barrel section. And that's a picture of it right there. And when we looked at this, building this airplane, not only do we want half the parts, we wanted to build it in half the time. We built the 550. So we went through and did a significant investment on how we went ahead and incorporated manufacturing technologies. We used bonded panels with stringers for the first time for us at Gulfstream. Never did that before. We used the design method called determinate assembly, meaning in manufacturing they couldn't put a part in the wrong place. It had to fit perfect. If it wouldn't go in if it didn't have it that way. And then we basically took all the parts we had at Gulfstream to do with rivets and bolts, and we reduced the part count by about 50%, and they had to use standard parts throughout the build of the airplane. So it was a big success. And then we actually did a pressure test on this vessel, and worked very well. We also prototyped the nose. This nose we built way ahead of the first airplane. And this nose went in the ITF that I showed you a picture earlier, but went very, very well. Once again, to validate the manufacturing technology and the engineering design in 3D. Our manufacturing facility, the 650 is a manufacturing facility. It got the code name during development called Building X. It's now called the Nick Shabraya 650 Manufacturing Center. And it is the building, you'll see it's kind of cooked a little bit to the side. Tell you how things go when you develop a program. That building is not supposed to be crooked like that. It was originally straight. And although we received all the permits from the Savannah Airport and the FAA and everything, turns out at the last minute they came back and told us, after we started almost construction, that the tower could not see the end of the runway because the building was blocking it. So we had to cook the building a little bit so the tower could see the end of the runway to the right. It's kind of a little last-minute thing, but thank God it worked out. We scrambled at the last minute to make that manufacturing center fit in that footprint. Unique to Gulfstream, our wingspan from tip to tip is 100 feet. So we basically have almost a 50-foot panel on each side of the airplane. We do not splice our upper covers at Gulfstream, and the reason is when our owners and passengers look out their windows, they see the upper cover. It is one continuous piece of aluminum. It is the largest sheet that Alcoa makes, and you can see the size of it. The lower cover we do splice, but the upper covers on every Gulfstream from the G1 through the G6 all are one piece. So we took the limit and made a one-piece upper cover. This is 6001's first bonded panel. It's made by Fokker over in the Netherlands in Papendrecht. And that's the Fokker team putting the panels together. You can see the bonded stringers. You can see the bonded doublers. The only thing that gets riveted on will be the frames, and we'll do that in Savannah. In the video, you see some pictures of that. And this is the horizontal skin. This is also made by Fokker. It's actually a joint venture with them in Sopka. It's made in Belgium. And it's been very, very efficient. It actually has a droop to it. 6001, this is the first airplane. This is a T, we call this T1, 6001. It's still in the Gulfstream livery. We use it in flight tests till today. Interesting enough, this is the fuselage mating with the wing. We can mate this fuselage to the wing in less than 45 minutes. It has about 12 fasteners that attach the wing to the fuselage. It's still redundant, but doesn't take very long at all to mate the airplane together. And then the tail comes on. The tail takes about 30 minutes to mount. The engines take about 20 minutes to mount. The landing gear takes about 25. It's like watching Legos go together. And most of that's attributed to the CATIA V5 and the Novia systems that we worked in. Oops. And lastly, on our airplane, our leading edges on the 650 are different than any other Gulfstream we built. All the other leading edges we have, if you're all material people in here, the 450, 550, the G4 to G5, all made with 2024 with a high polished clad surface. It's a #1 warranty issue on those airplanes because our customers always polish their leading edges and the clad wears off and doesn't look good. So on 650, we went to bare aluminum 6061 T6. It's a softer aluminum. So this is an example of a bird strike test. You can see we shoot the bird to make sure it doesn't penetrate the front spar, cause fuel leaks, and you can see the bird gun to the right there, and we shot the bird into the leading edge, and worked out pretty well. We're pretty thankful. I'll talk about the cabin real quick. We talked about it being 14 inches wider, more volume, larger, pitch the seats different, pitch the windows different. We worked on noise, and I'll show you a noise drop. But one of the things I really want to point out on this slide is we termed, my boss termed, press named this Cabin Essential, and it is a trademark of Gulfstream. And this is a first for us at Gulfstream is there are 5 components inside the cabin that we treated as an aircraft primary system, so there'll be no single point failure. We treated water, waste, lighting, power, and cabin entertainment all without a single point failure to a 10 to the -7 probability of failure. Pretty interesting to do. So what you end up doing is you have redundant systems. Like we have 2 water tanks, we have 2 lavatories, but we termed Cabin Essential, and it's actually worked out pretty well. Here's a picture cabin. On every green airplane and in every completed airplane, we do what we call a cold soak flight. Planes actually, as you get up to about 48,000 feet, the temperature change, and you sit up there for about 6 hours. Some funny things happen with expansion in the airplane. So we do cold soak flights, we do temperature surveys, we check for fits and gaps, and here's an example of an interior on a cold soak flight with positive results that we got back on the cabin temperatures too. I talked about windows. We had the biggest windows in the industry on the 550 and the 450. We talked to our customers. Our customers said, we love windows, can you make them any bigger? And they also said, hey, listen, when I sit in my seat, I have to droop and look down out the window. I don't like drooping, can you raise the window up? So you can see the biggest change, what we did on the 650. We raised the windows up 3.5 inches, made them bigger. And as everybody knows, when you put a big hole in an airplane, you have to reinforce it. It costs a lot of weight, and also to make the window bigger, these windows are not cheap either. So it worked out very well. Customers love the windows, the natural lighting that happens in the airplane. Here's a picture of the seating. We have hydroelectric seats in the airplane, certified. It's the first in the industry for us. And then also you'll notice that everything fully berths. We have touch controls. We have an app you can load on your Droid or on your Apple. You can raise window shades, do your lighting, change your gasper. Everything's touch screen inside. And like I said, you have your own, you can take your own personal phone and load the app, and the owners can come in the airplane and operators and change anything they want in the airplane from lighting. They can change the color lighting. It's all integrated. Talked about cabin noise. So on these cold soak flights, we put acoustic people on the airplane, and they have an image gun that we shoot. And when we hear noise, they have a sound meter, and we go look for the noise. And you can see here's up to the top, my top left, or your top right. You'll notice that you'll see some red areas. That means something's getting a noise out of what they're seeing on the thermal image. So when we bring the plane down to the ground, we then take the panel back and see what's going on. And in this case, you can see we have the insulation, and we use these studs to hold the insulation up, and the stud was actually hitting the panel, causing the noise. So, and like this one here is a table box. The table box also is the same thing. We noticed that it had some clashes inside that you wouldn't see normally. So we did, we paid a lot of attention to acoustics in this airplane with insulation and then, of course, noise. The fun part, testing, always fun. Exciting, but from my perspective, it's the best part of the program. The only thing I will tell everybody, when you get to testing, during development, you have a set schedule and time. When you get to testing and you find an issue, you have no time. It's 24/7, find a solution, get it back. And although you think everything's going to go smooth, everybody's going to run into something that they got to tweak or do. So you can't let the asset sit on the ground for very long. You want to get in the air, but you want to operate safe. So it becomes, even though it's fun, it does become a very stressful time for everybody. This is where you validate everything you worked on. So we also do lab testing. This is the wing. This is done in France, outside Paris, by a company, Intertechnique. We built, since it's the first time we've used their fuel system in Gulfstream, we actually built the third scale test article and did different altitudes and attitudes of flight to determine how the systems could read, the probes could read. So did a little bit of testing there before we went and flew the airplane. Also MABS, aircraft braking system, making aircraft braking system up in Akron, Ohio. We do a lot of testing. This is their dyno test. We do a worn brake test, and you can see how hot the brakes get. You take it to the limit and determine the stopping distance and what temperatures the brakes can take. So that went very well too. And actually, we do a real test on the airplane in Roswell to do max kinetic energy braking. Rolls-Royce, and this is in Dahlewitz, Germany, right outside Berlin. They built 5 test engines. You call them EDPs, engine development test engines. And we had them all over the United States. We had them all over Europe. We had them in England. They used 5 different test engines. Went very, very well. And you'll see some more engine stuff. But Rolls did an outstanding job with the development of test engines. All right, now, wing. The wing in the 650 is amazing. And I'll start by saying that I knew this statistic before we did this test, and this will make you nervous. 50% of all new wings break before they get to ultimate load. 1 out of every 2. It's pretty scary. So this is a nervous part of the program, and you're going to see how much this wing moves. And thank God we passed. Otherwise, we would have been in big trouble. So, but 50% of all new wings do fail. It's a known statistic. We also have a fatigue article going on. It's actually right now being tested. We've passed 2 lives. We're going to 3 lives. The regs actually take you to 2.5, but Gulfstream, we're taking it to 3. And that is going on as we speak today. Should be done by the end of this year. And before we fly, we've got to do a lot of testing on the airplane. One of the first things we do is we call a GVT, ground vibrational test. Although we do a lot of modeling, and when the engineers did a great job, the FAA still requires us to go ahead and do a GVT, and we want to do a GVT. And you can see we put shakers on the airplane, and we measure the vibration levels of the airplane. Also, not only do a GVT, we do a structural mode interaction test too to see how the plane reacts in the structural modes. And you can see we put the plane on bungees, and we simulate the structural mode interaction of the airplane. Pretty exciting test. And on top of that, we do HRF and lightning test. This is 6005, going through HRF and lightning testing, validating the wiring, the systems, separation, and how the airplane handles HRF and lightning. And then back in September, this is our first engine run on the first test article. That's about 11:30 at night. We ended up taking a lot longer than we wanted to because we were being very cautious. But there's Jake Howard, our chief test pilot, firing up the first engines, which was a very, very big moment for us. I'm not sure how many of you have all been in flight test and what goes on. We normally have about 5 airplanes in a flight test program. Each airplane has its own special mission. Number 6001, we determine it gets instrumented for performance. Then 6002 and 3 are our systems airplanes. 6004 does our F&R flying and does basically interior stuff and cockpit stuff and with 3. And then we have 6005, we call it, that picks up the cats and dogs, stuff we can't get. You'll notice RVSM is on the airplane. The FAA requires us to certify RVSM. We have to have a sample of 5 and and show that the variations aren't much. But we break down each test that's required for certification onto each airplane. And as a result, each airplane is instrumented to handle that test. 6001 is our performance airplane. It did our stall testing. You can see here's what testing the chute on the ground. Thank God we never had to deploy it, but you can see it doing testing. Handled very, very well. I have a slide to show you how it stalls. That is doing basically lightweight, low speed, take it up, an angle of attack, watch the airplane come and recovers itself out of stall. Climatic testing. I got quite a few slides on climatic testing. Over to your left, you'll see the world's biggest tanning bed. It's in Eglin Air Force Base where we can take temperatures up to about 140 degrees. In the same hangar, we can also make it snow. So they have a great chamber at Eglin Air Force Base down in Florida. That's where we took our airplane to do some climatic testing. And here's the team right there with the Gulfstream Rolls-Royce and the flight test team with 6002 going through climatic temperature testing. Also, another test we do, we did this at Wallops Island. This is called the water ingestion test. You want to make sure how the plane handles. Basically, put about 2 inches of standing water on the runway, and you land and you put the plane through it to see how it handles water ingestion. And you can see the plume of the water coming up from the nose, goes to the back. There's another one here. And you can see the best part, and it doesn't really get any water ingestion in the engines. And we successfully passed that water ingestion testing. Also, we went up to Canada. Unfortunately, on this test, we took 2 airplanes up there, test the cabin and also test the green airplane. And we only got to minus 20 degrees. So, but testing proved to be valid. We learned a few things, but the FAA requires you to get to minus 35 degrees Fahrenheit. So we didn't get cert credit for going up there, but we got a lot of company credit, and we learned a lot of things. And we went back to a place I've never been before in my life, and I hope I never have to go again. It's called Dead Horse, Alaska. You can see the welcome sign. It's right there on the Barents Sea, and it was cold. It was minus 37 degrees. The good news is the plane did operate fantastic, and we got to come home. So the other problem we run into is we're running out of cold weather. You can see the test in March. We were getting very, very nervous. We may have to go to South America to get the temperatures that we wanted there. Icing. Since it's a new airplane, a new wing, a new tail, we worry about how it performs with ice accumulation. And I'll spend a little time on this because from an aerodynamic standpoint, it's pretty important. You can see how we simulate the shapes. First, of course, you know, we model it through CFD and we look for the separations. But also then we go ahead and we actually put ice shapes, simulated ice shapes on the airplane, and we build them up and we fly. We build them up and we fly till we get to where we think it's. And we build them up for safety reasons. We want to make sure that although we have the analysis that says it's okay, we want to validate it. And interesting enough, what we build the shapes up with it's basically an epoxy glue with kitty litter to give you the roughness of ice. So and we spent a lot of time. This is not this test takes literally about a month to go through by the time you do all your build-ups to give you confidence. And you can see it's on the winglet with different ice shapes and how much holding time you need. Anyway, when you get through with all that company testing, now you got to go find ice. And we were running late in the program, behind schedule a little bit. And we were finally it was in May. And we were once again nervous. We were running out of cold weather. We ended up going up with the FAA up to Maine, up to Bangor, Maine, and performing some icing testing. We're looking for natural ice. That's how you have to certify the airplane. The green lines that you see up there is the flight pattern that the plane went through to find ice. And they go through different layers of altitude to find the ice. And then up in your right-hand corner, you'll see that's the horizontal leading edge, the ice accumulation that was built up due to ice testing. So good news is we found ice in May. Really good news is the plane performed fantastic. The FAA was very happy, so we passed the icing testing. But it is a very difficult test to pass and to build up to. We also went back to Eglin Air Force Base with 6001 and did some what we call this crosswind testing. They have a huge array of fans. You'll see them up there to the upper right. We went ahead and they simulate crosswind simulation, and we see how the engine, especially how the fan performs with crosswinds across the fan. And check for fan flutter and performance. I talked about EVS certification. We see through small particles of fog and rain. You can see what it looks like on half-mile visibility. About 50 feet this was taken. You can see the left is natural, what you see, and to the right you can actually see the runway through EVS. We did 17 approaches like that. Worked very well. So I'll flight test some of the flight test guys on functional reliability. When you do a new certification, even after you pass all the critical testing from the FAA, we call TIA testing, the FAA then requires you to fly about 300 just normal flight hours to prove how functional and reliable the airplane is. So we fly around with the FAA board for 300 hours after we finish all certification testing to validate the airplane is functional and reliable. And you can see the orange rack in there, it's a flight test rack. We spend a lot working with airplanes, and one of the beauties of CATIA 3D is what you can do, engineering can do with that data when you give it to the pubs people. We have interactive manuals on the 650, first time we did that, that actually illustrates pulling parts out, putting parts in. They can click on it, the thing, it's intuitive, it knows the part number, it tells you what it is. It's a pretty smart system. It's the first time we've really taken a step up into how we handle manuals and pubs, especially from a maintenance standpoint, and the FAA was livid and just loved that. We went through MSG3 smooth on this program. Here's a picture taken a couple months ago, a manufacturing facility. We're full swing. We're at not max rate, but we're moving airplanes through pretty fast. 650's got a huge backlog, thank God. And the manufacturing facility is very, very busy today as we speak. And then we were very fortunate, and we're very honored that the committee picked us for the Collier Trophy, and basically it's for the development of business jet. 650 is an amazing airplane. It's changed the life of Gulfstream. It's changed the life of a lot of people. It's been fantastic, and we were very, very honored to receive this acclimate. It's a picture of the 650 team. We went up to Washington 3 weeks ago, and it was pretty exciting. All right, so some people ask me, is this about aircraft development? It's like a marathon race, and it's difficult, I'll be the first to tell you, but it can be fun at the same time, as challenging it may be. And my advice to everybody is, and it's very hard, you want to listen to customers. We all think we know what we're doing and we know what's right, but when you get a hold of the customers and they talk to you, they will damage your ego, and they have a right to. And you got to listen and be humble, and then you got to act on it. So it's very important. I tell everybody, listen to the customer. Also, listen to the airplane. The airplane will talk to you during flight tests. You'll see things going on. Just pay attention, listen. The schedule, I can't emphasize enough how critical schedules are. I mean, everybody looks at a schedule and goes, you got to be, when you develop these schedules, be very, very critical. Spend a lot of time going through the schedule. Go through what ifs, look at what you did in the past. Literally on the 650, I probably spent 3 months working just on the schedule before we launched. So I urge everybody, focus on the schedule. And then what we did on 650, we should have done more of it even, was prototype everything. Prototype it and test it thoroughly. Don't just prototype it, test it once. Keep testing it. Don't let go. But prototype anything you do and validate before you get to the first article and build it. Suppliers. Suppliers are critical. And my advice has always been their success is my success. I actually go out of my way to help them. Most of those turn out to be very good friends of mine. And I know it's a business, and it is a business. But work with them. And anytime I got in a crutch with a supplier, and you're going to get in with somebody's going to have their way and your way, and you're going to get in a disagreement on what's the right way to go. This is what I used, and I encourage you to use it. I used to always say to them, what's best for the airplane? And that just diffused everything. So you just say, hey, what is the best? Forget about what you think. Let's put what I think. What's the best thing for the airplane? So you come to a common ground, and it works very, very well. And then supplier qual. We sat these airplanes down and did many upgrades during the flight test program, software, hardware. Get through your qual test as fast as you can. Because what happens is you may get a safety of flight and pass on a certain actuator, but as you go through the endurance testing of the actuator, it may fail. It causes you to do an upgrade then too. So do everything you can to push qual testing and get it done as fast as you can. Spend extra money to get it done fast. And then I talk about labs. Labs, you never have enough of them. The SIB is a software integration bench. You have the ITF, you have the Iron Bird. Everybody, labs will make you or break you. So overuse them. Just spend as much time in the lab as you can to overuse the labs and work it out before you get to the airplane. And then the FAA and EASA, just know the regs. Those guys have a job to do. They're not being, from what I've seen, they're very reasonable, but they have a job to do too. They're here, and So you work with them, know them, be forthright, be honest. If you think you got an issue, tell them. They'll be so thankful that you're working with them. And what I've seen is if you work with them, they'll help you. If you stick it to them, they're going to stick it to you. So work with the regs, work with the FAA, work with the AIAA. They're good people. And then budgets. Got this a rule of thumb I use. And if you're going to go into a budget, you better have at least a 15 to 20% management reserve because you're going to need it. Something's going to come up, and you're not going to have the money unless you have that in there. And any less than that on a new program you're going to go way over budget. And then, as talked about the team, I have a thing called the 98% rule. As a senior manager at Gulfstream, we get a lot of information. And your senior managers, where you work, will get a lot of information. I believe you can share almost everything with everybody. There's that 98%, 2% that you may have to hold back, but you should share everything you can with everybody and make them feel part of the plan and let them know what's going on. So we in the 650, we communicated daily to everybody. So, and then we would reward in meetings. Every day we have a meeting, we reward publicly and let everybody know what's going on and thank them for what they've done because, I mean, this is a big commitment to people and they deserve it if they've done a great job. The other thing on 650 is there was only one program manager, it was me. We didn't have very many layers of management. Some companies and some other programs do. So my advice is always reduce the layers of management. It may cause extra work for yourself, but in the long run, you get things done a lot quicker. And then what I always did was I pushed authority down to the lowest level I could. Let people make decisions. Let them go. Give them a sense of ownership, give them a sense of pride. And that will work out benefit. And like I said, make decisions. Don't be afraid to make a decision. Make them promptly. Don't be afraid to make mistakes. Everybody makes mistakes. I make mistakes every day. I made a mistake pulling in the parking lot here today. So just don't be afraid to make mistakes. Just don't make the same mistake twice. But don't be afraid. You'll be better off. So in summary, talk to the customers, get their input. It's critical. Engineering, I can't say enough. Fantastic. Their analysis, how well it correlated to everything in the test was unprecedented for me. I've never seen anything work so well. The airplane that does have 50% fewer parts than the 550. The labs is where I think it saved us on this program. The labs were critical in the development of 650. We're very, very honored to receive the Collier Award. That was the blessing, and we're so thankful at Gulfstream to have that. The plane is well received in the marketplace. Right now, I think the next available slot for a 650 is the fourth quarter of 2017. It's $65 million. That's pretty good right now in this day and age. And then the beauty about this airplane, it's not done. There's still more development going on in the 650. Obviously, you heard about the ER. There's other stuff coming in this airplane. Speed records will continue. And the best part about the speed records is our customers love to set them. So it's pretty exciting. So with that, I think I just want to show you our Collier acceptance video, if that's okay. Oh,
We got a number of questions for you.
okay.
I'm going to start with, what was your secret for holding cost on design and configuration changes if you made a lot of changes after the conceptual design phase?
Well, the secret first is you need management reserve, which is critical. The other is you got to be quick on your reactions. And I told you about layers of management and having a team that communicates. We streamlined everything, and we could turn models around literally in hours and get things to the floor. And we had a co-located team. That's the other thing we didn't talk about, but the other thing about the 650 was we had everybody co-located from manufacturing to procurement to engineering all in one location. So we could do things very, very fast. And that was the critical thing.
Next question. Awesome aircraft. Congratulations on winning this year's Collier Trophy. Looking ahead, what are Gulfstream's plans or aspirations regarding a supersonic business jet?
We get asked that a lot. That's a good question. We invest in supersonic technology. We have a supersonic team, and we will continue to invest in it, and we'll look for opportunities, but we can't make any commitments right now. But we will, and we do invest in supersonic technology.
Given the relatively low production volume, did you make much investment in the manufacturing automation on your new assembly plant? And kind of adding to that, we had a discussion before coming up here, and you were talking about your production rate, so you might want to share that.
Yeah, by the way, that's for us, anything more than 50 is big. Not like Boeing where they do 50 a month. 50 is a lot to us. So to us, we have a high production rate for the type of airplane that we manufacture. So the investment and the return, just remember, I'll tell, is public knowledge, but Gulfstream as a business returns over 17% margin every year. So you can see, did the investment pay off? Yes.
Okay, I noticed you use government facilities such as Eglin, Wallops, NASA Langley. How important is it to Gulfstream for the government to maintain, operate, and upgrade key facilities now and in the future?
Huge. The government has got to continue to support aviation. We rely heavily on those facilities, and it's in the best interest of all aviation that happens. So it's very, very critical. We, through Gamma, reinforce that. We also have an office in Washington that reinforces that, and we do all I can to make sure the government supports those facilities and funding.
I'm going to combine two questions here. Did you use an MDO strategy in order to consider the discipline interactions during the conceptual design phase? And the second part of it, what can you say about the relative use and synergy between wind tunnels and CFD during the development?
I'll start with the last one first, because I missed the first part. What was the first one again?
The first one was on the using MDO for designing the airplane.
MD?
Oh, multidisciplinary optimization.
Let's start with the wind tunnel data, and the CFD was, I mean, I think if we missed by more than 1% of the drag and what we saw in handling characteristics and divergence of flow. Matter of fact, after we flew the 650, we usually do a thing called flow viz. I don't know if everybody's, or you put tufts on the airplane. And we tufted the 650 looking for drag and any shock waves, and we didn't see any. So the CFD and the wind tunnel data correlated flawlessly. As far as MDO, the team's all, the best part of being that what General Dynamics allowed us to do was build those facilities, get everybody co-located. We work concurrently together with everybody from manufacturing. You know, it's easy for an engineer to design something, but can you build it? So as an integrated team, it was, being co-located was flawless.
How did schedule performance compare with the original plan, and where were issues, if any?
You know, every company I've ever been at, we have internal goals and we have external goals. And internal goals are usually, we call them stretch goals. So we have this stretch goal on a schedule, and then we have a normal schedule. We met the original schedule. We missed the stretch goals by about 3 months. As far as budget goes, 650 maintained its budget. We were, with the reserve I used, we actually built the airplane and did the research and development side all within budget.
Okay, we'll make this the last one. You mentioned getting input from your customers on the windows. Can you talk any more about how you work with your customers to design the cabin interior or possible other features on the plane?
No, that's a good question. We have a thing called ATCAT. It's called Advanced Technology Customer Interaction Team. And what we do is once a quarter, and we rotate this. Every 2 years, we get new customers in. But we bring them into Savannah, and we pay for them to come. And we sit in their room for 2 days, and we go through technology. We walk them through mock-ups and demos, and we get their feedback. And then when they come back the next quarter, we have all the actions, and we go through, and we show them the changes and how we incorporate it. So they basically give us a lot of interaction on our design. And we maintain that ATCAT. It's huge for us. The customer input is so valuable because they're the users, and they see more than we see. So it works very, very well.
Okay, beautiful airplane. Thank you very much, Kurt.
Thank you.
I'm sure if there's anyone who wants to make an order, you'll
I'll be happy to take it.
Yeah.
Thank you. Thank you.
Thank you.